Welcome back to Mathematics Lifeline. In today's video, I want to show the different types of numbers. So I've made this diagram here with 6 different classes of numbers. We have the natural numbers, the whole numbers, the integers, the rational numbers, the real numbers, and the complex numbers. And I want to show you what numbers are in each of these sets and how we can classify them given a number. So first I want to talk about the natural numbers. The natural numbers is the starting point. So these are called your counting numbers. So usually we denote the natural numbers with a capital N. And the natural numbers are your basic numbers, 1, 2, 3, 4, and so on. So these just go on forever in that direction. But we only have 1, 2, 3, 4, and so on. So that's why they're called the counting numbers. Now the whole numbers, a lot of times we denote these with just a capital W. And many times people will group these in with natural numbers because the only thing that whole numbers add is the number 0. So we have 0, 1, 2, 3, 4, so on. So it's the natural numbers plus 0. So again, a lot of times people will group them together. I like to keep them separate because they were a different class. Now let's talk about the integers. The integers, and this is where this starts to make no sense in terms of the lettering here, but integers are commonly denoted as a capital Z. So integers are essentially the whole numbers and their opposites. So we have the whole numbers, 0, 1, 2, 3, so on. But we also have -1, -2, and so on. So it goes in both ways, positive and negative numbers, but there's no fractions, there's no decimals. It's just the whole numbers, but they're also their reverses. So now rational numbers. Rational numbers, again, doesn't make much sense, but we denote this with a capital Q. So rational numbers are any number that can be expressed as a ratio or as a fraction. So as an example, we have 1/2. 1/2 is a rational number because it can be expressed as a fraction, but it is not an integer because it's not just one of these basic numbers. It's not one of the whole numbers or the whole numbers opposite. So with this, we also have 1/3, which this confuses a lot of people because 1/3, when we write it out, is 0.33333 repeating. However, it can be expressed as a fraction as just 1/3. So now we can also express integers as fractions. So let's take the number 2 as an example. 2 can be expressed as 4/2. So 4/2 is a rational number, which says that 2 is a rational number because 4/2 is equal to 2. So this is how you can describe rational numbers, anything that can be expressed as a fraction. Now let's talk about the real numbers. Now the real numbers include everything. So it includes the irrational numbers. And irrational numbers are numbers that cannot be expressed as fractions. So an example of that is the number pi. We know that pi is an infinite decimal. It will never stop and it never has an end. So it keeps on going forever. This can't be expressed as a fraction, so it's only a real number. It's not a rational number. Another example of this is the number e. E cannot be expressed as a fraction. E is, again, just like pi, a constant decimal. It never ends. So it is not a rational number, but it is a real number. And then, of course, any of these are also real numbers. So 0, 4, -3/2, 18, all of these are also real numbers. So this is why I like to use this chart, because the real number is the biggest rectangle. That means that it includes all of the smaller rectangles. So if you have the number 3, it is also a whole number because the whole number box is bigger. It's also an integer because the integer box is bigger. It is a rational number and a real number, all because of the rectangles being bigger. So essentially, if you have a natural number, it is a member of all of these 5 rectangles right here. So we'll use that in a second to classify some numbers. And the final thing is the complex numbers. Also, I forgot to mention, real numbers are often denoted with a capital R. So this one makes sense. Complex numbers are usually denoted with a capital C. And these are all of your imaginary numbers, or numbers with imaginary components. So an example of this would be the number I, which a lot of you know is the square root of -1. Now, when you first learn these types of numbers, you might not be using imaginary numbers just yet, but this is part of math. You will use it later on. Another example are what's known as complex numbers. These are just imaginary numbers, just I is an imaginary number. Complex numbers are a real number, so let's take 4 as an example. plus some imaginary part. So let's just go 2i. That's a complex number. So anything that involves I that has an imaginary component is going to be in this complex category. And that's why this is completely separate, because if we see an I, we know it goes in complex. We don't see an I in any of these. So right now you might be thinking, what do we even use types of numbers for? Why do we need this? Well, a lot of times when you first learn this, you're learning this in early middle school, maybe even late elementary school, and you don't see the point of it at first. However, when you go into higher level math, when you start doing proofs, you use these all the time because sometimes you want to set restrictions on something based on what class of number that they're in. So, for example, if you only want to look at the integers, you want to use this, and we'll use notation to show that the only thing we want to focus on is in the integers, or in the real numbers, or in the rational numbers. So it's just a way to separate everything in a way that everyone has the same understanding of what these classes of numbers are. Okay, so now that we have done this, I want to do a couple of examples of classifying numbers. So we'll do that right after this break. Okay, so we're going to go ahead and classify the number 7. So we want to figure out, is 7 a member of any of these classes, or how many of them are there? Well, we know, because we don't see an I, that complex is already out of the equation. It's not a complex number. So when we use this diagram, we know it's between these 5 categories. When we use this diagram, we want to look to the first time we see 7 in the lowest possible box. So, for example, natural numbers, 1, 2, 3, 4, 5, 6, 7, so on. But we see 7 in the natural numbers. And natural numbers are the smallest box. So we know that it's already in the natural numbers. And since it's in the natural numbers, and natural numbers is the smallest set, the smallest box, we know that it's also in the whole numbers. It's also in the integers. It's also in the rational numbers. And it is a real number. So this fits in all of the classes except for complex numbers. So that's our first example. Let's go ahead and do another one. All right, so our second example for this is we want to classify the number -4. So again, the first place we always want to start is making sure it's not a complex number, because if it's a complex number, we know it's not any of the rest of these. So we know that there's no I in this. It's not a complex number in this form. So we know that it is not a complex number. We can rule that out. So now let's look at all these classes, starting from the lowest, and then we'll see which one it's first in, and then everything above that it will also be in. So let's look at natural numbers. Well, we know natural numbers starts at 1 and goes to the right on the number line. So we know that it will never become negative. So natural numbers will not contain -4, so it's not a natural number. Whole numbers, remember, are the natural numbers, but with the addition of 0. And -4 is not 0, so just the same as it's not a natural number, it's also not a whole number. Now with integers, we include all the whole numbers and their opposites. So we know that 4 is a whole number, so its opposite is -4. And we see that it will go to -4, -1, -2, and it keeps going on to -3 and -4. So the first time we see it is in the integers. So we know it's an integer, and because integers are smaller than the box for the rational numbers, and it's smaller for the box than the real numbers, we know that they're also, -4 is also a rational number and a real number. So that's how we can classify -4. So let's do another example. Okay, so here's another example. We want to classify the number 2π. Now this one is pretty tricky because we know that pi is never ending, but we know that 2 is even in the natural numbers. So which one do we consider? Well, the trick for this one is to realize that pi is never ending. So no matter what we do to pi, it will not end. If we divide it by something, if we multiply it by something, if we add it to something, the final thing, if it has pi in it, will not end. So we know that this number is a decimal that never ends because we have a pi in there. And we know that the first time we see pi is exclusively in the real numbers. And the real numbers is, it includes those irrational numbers, which is what pi is. So we know that it's not a complex number because we don't see any I here. And the first time that we see anything involving pi is in the real numbers. So the number 2π is exclusively a real number. So let's do one final example before this video ends. Okay, so for the last example I want to do, let's classify the number 7/8, or 7/8. So again, we don't see it in the complex numbers, so that's not going to be an option. Complex is already ruled out. So let's start from the bottom. Let's see where we see it. Well, we know that natural numbers are just the counting numbers. So again, 7/8 is not going to be there because it's not one of the counting numbers. So natural numbers is out. Whole numbers only add 0 to the natural, so we know that 7/8 isn't 0. That tells us it's not a whole number either. Integers are whole numbers and their opposites. So we know that 7/8 is not a whole number, so it can't be the opposite of a whole number. So we know for a fact that it's not in the integers. Now this is where we see it. The first time we see it is in the rational numbers. We see that 7/8 is a fraction, which means it is a ratio. So since it is a fraction, we know that the first time we will see this is in the rational numbers. So we know for a fact that it is a rational number. And because the rational number box is less than the real number box, it's lower than the real number box, we know that it is also a real number. So that is how we can classify 7/8 using these 6 classes of numbers. So that's all I have for you in this video. I hope that you've got some more insight on these types of numbers. I know that immediately they might not be as useful to you as what you want them to be. But if you do more math and if you go to college and do math, you'll see this all the time. And you'll really need to know what numbers are in these different types of numbers. So although it doesn't make much sense or it might be new to you right now, make sure you learn these and make sure you know how to use these because they will be useful to you in the future. But like I said, that's all I have for this video. Please let me know if you have any questions or comments. But if not, I will see you next time. Thanks for watching.